So I'd like to continue talking about prime factorization, particularly how to break down larger numbers like 500. There are some tips and tricks I can talk about that will aid in the process of breaking these large numbers down. So do you notice that 500 ends in 2 zeros? That means that 500 is divisible by 100. So whenever you see that there are zeros at the end of a number, that will tip us off to that this number is either divisible by 10 or 100 or 1,000 or 10,000, depending on how many zeros there are. There are 2 zeros. 2 zeros is divisible by 100. Okay. Now 5 is a prime number. I can circle it right away. Now 10, there's so many ways to break 10 down, 100 down. For instance, 10 times 10. You could have done 50 times 2. Still would eventually come out to the same numbers, 10 times 10. Now each of these 10s are broken down into 2 times 5s. And since 2 times 5 and 2 times 5, all of these are prime numbers, these factors cannot be further broken down. So we're done. So if I were to write my answer, I would say 2. By the way, when I write my answer, I usually then cross out the number so I know to not skip it or double count it. So it's just a technique that I use. So I wrote down this 2. I'm going to write down this 2. I'm going to write down this 5 and this 5 and this 5. So if you were to multiply 2 times 2 times 5 times 5 times 5, you get back to 500, and all of these factors are prime. If these factors were not prime, that means I have more work to do to break these factors down even further. But this is as far as I need to go for 500. So we just came up with something that's called a divisibility rule. Remember, if something ends in a 0 or double zeros or triple zeros, that is a cool divisibility rule. So let me go over divisibility rules. Okay. So, as we said, if something ends in a 0, 0, 0, 0, 0, 0, like this, it's going to be divided by, if it ends in just 1 0, by 10, 2 zeros by 100, 3 zeros by 1,000, and so on and so forth. So those are good divisibility rules. Probably the most basic one is all even numbers are divisible by 2. Even numbers divisible by 2. Here's a really cool divisibility rule. It's the divisibility rule of 3. Let's say we have 3, 6, how about 3, 6, 6? Sure. So if you add up the individual digits of every single number that makes up the complete number, and that sum is divisible by 3, then the entire original number is divisible by 3. So for instance, 3 plus 6 is 9, 9 plus 6 is 15. 15 is divisible by 3, thus 366 is also divisible by 3, okay? And it works with any number. Let's say 471, let's add it up. 4 and 7 is 11, 11 and 1 is 12, 12 is divisible by 3, so 471 is divisible by 3. I'll prove it, here. Let's see, 3 into 4, 1, 3, 1, 7, 3 goes into 17 5 times. 5 times 3 is 15, 2 carry down to 1, 3 into 21 is 7. Turns out that 3 goes into 471 exactly 157 times. So that's the divisibility rule of 3. Also, the cool thing is, if follow that same divisibility rule, and it's true for 9 as well, as long as the number adds up to a multiple of 9. So let's say, how about 870, how about 873? Okay, so let's add these up. So 8 and 7 is 15. 15 and 3 is 18. 18 is divisible by 9. Thus, 873 is also divisible by 9. So do you see how the divisibility rule of 9 is similar to the divisibility rule of 3? If you add all the digits up and it's divisible by 9, then the whole thing's divisible by 9. If you add them up and they're divisible by 3, then the whole thing's divisible by 3. Okay, so those are divisibility rules of, I'll just call add the digits, okay, as a shorthand, and that'll give you for 3 and 9. Another one that you probably already know, if it ends in a 0 or 5, it's divisible by 5. So like 75 ends in a 5, so it's divisible by 5. 70 ends in a 0, so it's also divisible by 5. So these are some common divisibility rules. Another one that I like to say is if a number ends in 25, 70, 50, 75, or 0, 0, the whole thing is divisible by 25. So that's the divisibility rule of 25. So for instance, 550, it ends in a 50, so it's divisible by 550 is divisible by 25, okay? So these are some good ones. There are lots of others, lots and lots of others. There's the divisibility rule of 4, divisibility rule of 11. I would check that out on the internet. Divisibility rule of 11 is really cool. So these are the ones that I would, sort of the usual suspects that I would use, but there are definitely others out there, but this is a good place to start, and I'll let you practice a little bit using your divisibility rules.